So what we're going to do is we're going to set up our player now, which is going to get them moving and jazzing and bebopping and doing all that stuff. So what we're going to do is we're going to go ahead and locate the player model, which is going to be located in Models folder, and we're going to expand that, and we're going to look in the Characters folder, and we should see a player. There we go, player, should be right there. And so what we're going to do is we're going to go ahead and drag that either into the scene or into the hierarchy view. So just click and drag and drop, and there he is. And there he is. Looking pretty swaglicious. And so obviously if we just click and drag him into the scene, he might go wherever, so we need to place him at a specific spot. So we're going to ensure that the position is at 0, 0, 0. If it is, then you're golden. If it's not, go ahead and set it to 0, 0, 0. By typing 0, 0, 0, or again, we have this cog or gear icon, and you can just click reset or reset position, which will put it where we want it to be on the origin. Now, we need specific things to interact with the player in a very special way. And so we want to ensure that we've properly tagged our player so certain things will know when they've come in contact with the player. To do that, we have this tag dropdown here in the inspector, and currently says untagged. And what we're going to do is we are going to click that dropdown, and we are going to select player, thus tagging our player as the player so that the player will behave appropriately when they're playing, right? All right, fantastic. Now, what we need to do is we're going to go ahead and create an animation controller for our player, which is going to allow us to have all of the neat little animation effects of moving and turning and doing all that stuff. And I'm still zoomed in here. So what we want to do is we want to go ahead and locate the animation folder, which we'll just click on right here. Currently, it is in fact empty. And we are going to make an animator controller.
Should we just talk a little bit about the animations that we've set up first?
What a great idea.
Cool. So the model that we've just dragged in is the player model. And what you can do is drag up the preview window in the lower right of the editor. So this model has been animated for you. So when you bring in an FBX into Unity or a Maya file or 3ds Max, whatever package you use, when you bring that in, you can store animations within it, or if you have a humanoid, a biped type model, you can retarget those animations onto similar type of models. This particular thing is rigged in what we call a generic manner. So if I look at my rig, you can see generic up at the top. And what that means is it's a very specific bone structure because our character is going to move like this. It's going to be kind of hopping around. So he's not got 2 arms, 2 legs as a kind of biped would. So the animations that are stored in this particular game object, this model that we've given you, are a move, an idle, and a death. So what we're going to do now is to create a state machine called the animator controller to control when these 3 different animations are going to be played back.
If you're looking in the inspector here, I highly encourage you not to touch anything, right? Because these changes change how Unity imports the stuff, and if you just start clicking, a little box comes up and it's like, would you like to apply? And you're like, yeah, apply for what? And then all of a sudden, your stuff is not going to work later. So just...
so we're doing
look,
this just to show you where the animation is going to be coming from, and we're going to go ahead and actually implement it now.
All right, so we're going to go back to this animation folder, and again, it's still empty, so no magic there yet, right here. And we're going to go ahead and add what's called an animator controller. Animator controllers are part of the Mechanim animation system. They're basically a finite state machine that just blends animations and does all this neat stuff. It's actually magic. We hired wizards. And what we're going to do is we're going to go ahead and create this asset that's going to allow us to do that. So I'm going to right-click here inside this, inside the animation folder in the project view here, and I am going to select create and then animator controller. Not animation, not animator override controller, but animator controller. And I'm going to get this name here, and I'm going to name it player AC for animator controller. There we go. And so once we have that, what we're going to do is we are going to actually just click and drag that onto the player, which is going to apply this animator controller to the player. So I'm not going to put it under the player, I'm going to put it on the player, and you'll know the difference because player itself will become highlighted. And I'll let go. I can confirm I did this correctly by clicking on the player, and I see here player AC is now listed in the animator component, player AC, right there. That's how I know I've done it correctly. All right. Now, let's go ahead and look at this animator controller. now that we have it created. And to do that, I can go to Window, and then select Animator. But easier yet is to see my player AC and just double-click on it, which is automatically going to open up the Animator window. If it's not docked here, you can just dock it by clicking the tab, dragging it, and docking it into the window. So as we were looking at earlier, when Will clicked on the player FBX model, and we looked in the inspector and we saw those animations and stuff that was baked into those settings, those actually create assets that we're able to use. So if I go back to the models characters folder right here, and again, look at my player.fbx. If I were to expand that, I would actually see the assets that make up this imported model. And so I'm going to go ahead and click this arrow here. And what I see is I see these 3 animations, death, idle, and move, right? So not only were the animations imported as part of the model, but we actually have them as assets that we can utilize. And so what I'm going to do now is I'm actually just going to take each of these in turn and move them into my animator window. I'm just going to click and drag them and drop them. I'm just going in order here, so I'm just going to do death, idle, and move. The order's not really going to matter because we're going to reorder them in just a moment. So when you have this done right, you'll see that you have this any state, and then you have a death state, an idle state, and a move state. All right, and so we'll notice that the death state is orange, or whichever state you dragged in first is orange, right? Orange means it's the default state. Obviously, I do not want death as the default state. It's a sad game, but it's not that sad. And so what I want to do is I'm going to set a different state as our default state. So I'm going to right-click on idle, and I'm going to click set as default. And so that will then turn orange. And I can reorder just by clicking and dragging and moving things around. If you just happen to be very particular about how things look, you can start building yourself some geometric structures if you really feel like it, whatever. But anyway, so now we have idle as the default state. And so what we need to do is we need to tell the animator when we want to transition from one state to another state, right? So we've got these 3 states. We've got idle, we've got move, and we've got death. And they're self-contained animations. They can just play and all that stuff. But the logic of when we go from one to the next isn't currently in here, right? So what we need to do is we need to create something called a parameter, which is basically going to control when something happens, when something changes state. And we access those parameters right here with this little parameters button. It's very cleverly named. And we have this little plus icon right there. And what we want to do is we want to create a parameter. So the first parameter we're going to create, when we click this, we're going to see we have some options. We can create a float as in a floating point number, int as an integer, bool as in boolean, or trigger. We want to create a boolean, so bool, and we're going to call this is walking. It's very important that you spell it right, like I just did not. There we go, is walking, and then enter. It has to be capital I, lowercase s, capital W, walking. All right? It's important that it's spelled right because we have scripts that you're going to use that reference it by name. So if you name it something else, like Skeletor, when the time comes, it's not going to work. You'll just have to open up. You're going to have to open up your code and actually change it, which you really don't want to do. Nope. So we have this is walking, which is a Boolean, which means it could be either true or false, and that true or false will dictate whether he is walking. I'm going to create another one now. So again, I'm going to click this little plus icon, and I'm going to select this time a trigger. And a trigger is like a Boolean. It can have a state true or false. But unlike a Boolean, the moment we set it to true, it sets it back to false, right? Which is useful when I just want to like trigger something to happen one time, and then it resets itself, right? So we're going to select a trigger here. And this trigger is going to be called, you ready for this? Die. We listened to a lot of heavy metal while making this. And so die is a trigger that's going to be triggered when the player actually dies. All right, so now what we want to do is, so we have these parameters, which is, great, but now we need to tell Mechanim in the animator specifically how to use those parameters. We need to set up some logic to move us from one to the next. Oh, you're reordering my stuff.
I'm reordering it wrong as well.
All right, so what we want to do is we want to set up transitions, all right, that basically says, hey, this state is capable of going to that state, right? And this state is capable of going to that state. We set up these transitions explicitly so that we can't accidentally transition from, say, like dead to jump, right? Because that doesn't make a whole lot of sense. So what we want to do is we want to create these transitions, which basically are one-way bridges that define logically how we go from one state to another. So what I'm going to do is I'm going to right-click on idle, and I'm going to select Make Transition. And when I click Make Transition, I get this cool little rodeo lasso thingy, which is actually just kind of fun to play with by itself. But we're here for business. So what I'm going to do is, once I've confirmed that there's this white line attached to my mouse, I'm going to move my mouse over the Move Animator state, and I'm just going to click, and it's going to connect the two. So now what we have is we have a transition from idle to move. Yep, see, there you go. In case you didn't believe me. And so this is basically saying that we can go from idle to move. All right, so what I'm going to do now is, in order to actually dictate when that happens, I have to click on the transition. So I'm going to get real close here.
Too close.
Too close. There we go. And I'm going to click, and you're going to see it turn blue. All right, and so now I have selected the transition between the two. And once I've done that, over in the inspector view, we get the properties of this transition. And what I'm interested in is down at the bottom, we have these conditions. What is the condition of this transition, right? And so what I'm going to do is I'm going to click this little drop down right now that says exit time, and I'm going to select is walking, and I'm going to leave that as true. So the way you read this is we are transitioning from idle to move when is walking equals true. Right, cool. All right, and so now what I'm going to do is I'm just going to kind of do the exact opposite. So I'm going to right-click on Move, make transition, get my fun little rodeo arrow. Now I'm going to click on idle. So this is stating that I am able to move from the move state back to the idle state. And I'm sure you can all guess what the condition for that's going to be, but we'll go through it anyway. I'm going to select conditions is walking equals false. So if the player is walking, we play the walking animation. If the player is not walking, we don't. We play the idle animation. All right, finally, what I want to do is I am going to create one more transition. This time, we want the player to be able to die. And so to do that, we're not going to transition from idle or move or death, because we can theoretically die in any state, depending on whichever animation is currently going on. So we are going to use the any state. All right? And by that, I mean the actual green any state. I don't mean you're going to transition from just any state you want. All right? So the one that actually says any state. And so I'm going to right-click on that, and I only have one option, and that's Make Transition. And I'm going to transition from any state to death. So no matter what state you're currently in, if you die, you die. I'm going to select that transition. You'll see it turn blue. And I'm going to set my condition to be die. Now, since it's a trigger, I don't need to specify true, false, value, or anything like that. It's just if die gets triggered, we immediately switch into the death animation.
The next thing we need to do with this player character is to give him a physical presence in the scene. So if you change from your animator window back to the scene view using the tab at the top, then you can select the player. We're going to add a rigid body. A rigid body component is something that allows the physics engine of Unity to be applied to the object. So we are going to click Add Component and choose Physics and Rigid Body.
It's important that you don't select Physics 2D, Rigid Body 2D. We're doing 3D physics, so yeah. Just physics.
Cool. So then what we're going to do, because we don't want this to kind of slow down over time, we're going to set the drag and angular drag to infinity. So you can do this actually by just typing INF in the drag box and hitting return. If you've done it correctly, you'll see a capitalized infinity. We do want to use gravity. We want to keep the player firmly grounded, despite this being a dream sequence. And we do want to use constraints. So basically, we're going to use constraints to ensure that the player character doesn't fall forward or fall over any different direction. And we also want to freeze the Y position so that he doesn't sink through the floor or jump up or anything like that. So in freeze position, we're going to choose the Y coordinate and freeze rotation X and Z or Z.
You'll have to expand constraints if it's not currently expanded.
Yeah, sorry. You need to expand constraints. If you can't see those properties, you should see them at the bottom.
Next, we need to make sure things can actually bump into the character, because currently he reacts to physics, but if he doesn't bump into anything, nothing's going to happen. So if you go to Add Component, and then Physics, and then there's a capsule collider along with all the other colliders there. And we need to give it specific settings so we make sure that the capsule covers the player. So if you change the center to 0.2 in the X, 0.6 in Y, and leave the Z as 0, or Z as 0, sorry. And we also need to change the height to 1.2. So what that's going to mean is that this sort of leaning over character thing here, he's got a little bit of an X offset, so the capsule is going to cover him nicely. So next, we need the player to make a little yelping sound when he gets hurt. So we're going to add an audio source component. So if you go to add component audio, and then find audio source, and we're going to change the audio clip from none, using the little circle select by it, to player hurt. So when it opens the context-sensitive menu, you can see player hurt there.
One thing about the selection window is that you can double-click to close it at the same time. If you want to assign something, you can open up the circle select, double-click will also close the window. One other thing I'm going to quickly do, because we've got these settings done, is I'm going to close the rigid body, or collapse it up using the arrow next to it, just so that we can see the ones below it.
We do not want the player to make a yelp sound on awake, so we're going to uncheck play on awake. You'll know that if you haven't unchecked that, when you start the game it'll go, oh! If it does that, go back to this and uncheck play on awake. Right, so we're going to find the player movement script, and that's in the scripts player folder. So if you look in the project panel, you find scripts, expand that, and then click on player. You'll see on the right-hand side the different player scripts that we've got. And we've got an empty class called player movement, and we're going to go through making that now.
Okay, so you can assign a script a number of different ways. So a script is just a component like any other component. But what we're going to do is we're going to drag and drop for this one. So I'm going to grab my player movement script, I'm going to drag it up and drop it onto the player game object. When that's done, you should see that it appears as a component at the bottom of the list.
Be sure to save your scene before we go on to this next part too, because we're on a beta software.
So first of all, double-click it for opening, and you should get mono-develop to come up.
So there's a number of different ways to open a script. You can either double-click the icon in the project panel, you can click open with it selected at the top of the inspector, or one final way is to, when it's applied as a component, you can actually click the cog icon and choose edit script. If you give it a moment, it's going to open up the script editor for Unity, which is mono develop.
So all of this is going to be done within the class. So you notice there's a pair of curly braces or brackets. Okay, so what we're going to start off by doing is making some variables that we can adjust throughout the course of the class. So we're always going to start off with our public ones at the top, and then underneath with private ones. So we'll start off with a public float called speed, which is obviously going to control how fast the player is. I'm going to give it a default value of 6. So the F on the end there is just saying that this is a floating point variable. Now we move on to the private variables.
So I'm going ahead to type vector3 because vector2 is the first thing it suggests. I could accidentally press return and get that. I want a vector3 type of variable. So these variables we're declaring the type of them first. If you're familiar with JavaScript, you'll remember that it does it the other way around. So in C# we say the type of variable first and then the name.
So this one's going to be called movement, and we're going to use that to store the movement that we want to apply to the player. The next one, we're going to have a reference to the animator component, and we'll call that anim. We're also going to have a reference to the rigid body component, and we'll call that player rigid body. So the next one is an integer called floor mask. Now I'll explain this one. If you remember earlier we made that floor quad, that big square that we just left on the floor. That's the thing that we want to raycast into. And the way we tell our raycast that we only want to hit that floor is we use a layer mask, which is stored as an integer.
If I hit save right now, basically we designed this project on a PC, we've opened it on a Mac, files have different line endings, it doesn't matter at all, just hit convert, everything will be fine.
So the last private variable that we're going to make is a float called cam ray length. So that's going to be the length of the ray that we cast from the camera. And we're going to give that a value of 100.
The next thing we're going to do is go ahead and set up those references.
So we're going to set up the references in the awake function. So some of you will be familiar with the start function. Awake is very similar, but it gets called regardless of whether the script is enabled or not. So it's good for setting up references and things like that. Okay, we're going to start off by setting up our floor mask, and we're going to use layerMask.getMask. So then we can pass in a string, which is just a word or a sentence, of the layer that we're going to get. So we put the floor quad on the floor layer, so we're going to get mask from floor. Then we're going to use getComponent to get the references to the animator, like that.
You'll notice the little angled brackets there. That's just denoting the type of what we're looking for. In this case, we're looking for an animator, so we write animator. If we were looking for a rigid body, we'd write rigid body, and so on and so forth.
So, like we are, getComponent rigid body here. And that's all we need to do to set up the references. So next, what we're going to do is put a call to fixedUpdate. So fixedUpdate is a function that Unity will automatically call on its scripts that fires every physics update. So Unity runs on a number of updates. The normal update system that you're familiar with runs along with rendering. The fixedUpdate runs with physics. So since we're moving a physics character, he's got a rigid body attached, we're going to use fixedUpdate to move him. So what we're going to do is get the input from the horizontal and vertical axes, but we're not going to get the standard input. We're going to get the raw input. So whereas a normal axis would have values varying between -1 and 1, the raw axis will only have a value of -1, 0, or 1. It won't have any variation in between those. So what that means is that when we're controlling the character, rather than him slowly accelerating towards its full speed, he's going to immediately snap to full speed, which will give us a much more responsive feel.
Just so you know, an axis is actually input, right? So these axes, horizontal, vertical, jump, fire 1, fire 2, those are defaults within Unity. So if you're wondering what horizontal is, it's in there. So the horizontal axis basically maps to the A and D keys as well as the left and right arrow keys, right? Either of those manipulate the horizontal axis. Pressing the A key gives me a value of -1 in the horizontal axis. Pressing the D key gives me a value of +1 in the horizontal axis. Vertical is another axis. It's the W and S keys as well as the up and down arrows. Fire 1 is your left mouse button or left or right control, so on and so forth. If you're curious, you can go into the input manager. I believe Will just had that up there for a second ago. And that's where these axes exist, and that's how we set them up. But the ones we're all using here are defaults, so there's nothing special that you need to do to get those.
Yeah. So you can go ahead and put in the vertical axis as well. We're storing that as a float called v. So these are private variables within fixedUpdate, so we can use them within specifically fixedUpdate. So remember that the variables that we created earlier are outside of these functions, so we can use them within any of the functions in this script.
FixedUpdate and awake are automatically called by Unity. They're monobehavior functions. But we can also make our own functions that we can call within those fixedUpdate and awake. What we're going to do now is create a move function that we can call in fixedUpdate later to move our character.
So we're basically going to split up the actual operations of this player movement script into movement, turning, and animation. We're going to put them into separate functions to keep them all modular.
If you make a move function, it's going to have two parameters, a float called h and a float called v, and unsurprisingly, those are going to be the input that we will pass into this function when we call it. We have this movement vector that we stored earlier, and we want to set the value of that. So if you type movement.set, then you get the chance to put each of the x, y, and z components of those. So we're going to use h for its x component. We don't want any vertical components, so we're going to put that as 0. We're going to use an f because it's a floating point. And then v for the z component. So what that means is x and z are flat along the ground. So the horizontal and vertical movement that we give it will translate to lateral movement in the game. Now we've set that, we have a bit of a problem, because if you move just in the z-axis or just in the x-axis, then you've got a value of 1, like a size of 1 for that vector. However, if you use both, then the length of the vector is different. It's 1.4. So we need to change that so that you don't get an advantage by moving diagonally. What we want to do is normalize that. So what that means is it's going to take the direction that we have, but it's going to make sure that the size is always 1.
Effectively make sure the player moves at the same speed regardless of which key combination you use.
We don't want it to move at a speed of 1. We want it to move with our speed. So we're going to times that by our speed variable that we stored. Also, this is called every fixed update. So we don't want it to move at 6 units per fixed update. It would move 6 units every 50th of a second, and we wouldn't see our player ever again. So instead, we're going to change it so that it's per second. And the way we do that is by multiplying by time.delta time. Delta time is the time between each update call. So if you're moving it by that much per 50th of a second, over the course of 50 50th of a second, it's going to move 6 units. So finally in this function, the last thing we need to do is actually apply that movement to the player. So we're going to do that using a rigidbody function called movePosition. So movePosition moves a rigidbody to a position in world space. So we need to move it relative to the position that the character currently is. We need to add our movement to the player's position, the transform.position plus the movement. So it's going to be his current position plus this input that we've given him to move him slightly further along.
Next thing we're going to do is look at the turning of the character.
Again, we're going to make a new function. This time we're going to call it turning. Don't require any input for this, any parameters I should say, sorry, because the direction the character is facing is based on the mouse input rather than the input that we've already stored. The first thing we're going to do is create a ray that we cast from the camera into the scene.
Let's have a little look at how that actually works first. If you have a look at this diagram, we have a representation of the camera, the screen, and the level plus the floor quad around the level. So that box that you're looking at there is effectively your level. The floor quad is around that. And the camera, if you think of the camera as something that's looking from where you're looking at the game on the screen forward onto the game level, you can cast a ray, a single sort of invisible line from that point to the floor quad to get a particular position back. And we want to use that because we want the character to turn and face the point of wherever the camera's looking. So when you move the mouse around in the game, he's going to turn around and face that position so that you can turn around and also shoot in a particular direction.
So we see this end bracket on line 40. Make sure that's there. So a real quick gotcha that everyone always does is they move their functions down outside of the class by accident, right? So if you have void turning with your open and closed brackets and you don't have another bracket immediately after that, you missed one. And don't just add another one because then you're going to have one in the wrong spot and another one in the wrong spot. Instead, just move that function back up so that it is inside the class.
So the first thing we're going to do in this function is going to create a ray. So we call that camRay because it's a ray coming from the camera. And we're going to use a function of the camera, the main camera, called screenPointToRay. So what that's going to do is take a point on the screen and cast a ray from that point forwards into the scene. So the point that we're going to give it is the mouse position. So it's always going to find the point underneath the mouse, if you imagine. So if you're looking at the game, there's a mouse on your screen. The point underneath that mouse is the point it's going to find if that hits the floor quad. We need to get information back when we do this raycast. And in order to get information back from this raycast, we need a raycast hit variable. So that's what we're creating here. So the next stage is to actually cast the ray that we've created. So we created this imaginary invisible line, and now we need to actually perform the action of casting the ray so that it can hit something. Now a raycast function will return true if it has hit something, and it will return false if it hasn't. So we're going to put that inside an if statement. And if it has hit something, then the code within the if statement will be carried out. If it hasn't hit anything, then the code within the if statement won't be carried out. So we'll just skip out of this function. So that's what that little if at the start there is for. So we need to give this a number of parameters. Let's start off with the ray itself. That's the positions and directions of the cast that we're going to have. We need to use an out variable for the floor hit. So out means that we're going to get information out of this function. And we're going to store it in that floor hit variable. Next, we need to give it a length. So how far are we going to do this raycast for? And that's the variable camRay length that we store earlier. And finally, we want to make sure that this raycast is only trying to hit things on the floor layer. So that's that floor mask that we created earlier. So remember, since this is an if statement and a function, there should be two closed brackets at the end there, or two closed braces, sorry. So if you see, you've got if, open brackets, physics.raycast, open brackets, and then at the end, we need to close both of those brackets again. Okay, so we've got the open curly braces afterwards, and this will be the code that's carried out if we've hit something. So we need to create a vector 3 from the player to where the mouse has hit, and that's the floor hit dot point. So that's the point that it's hit the floor minus transform dot position. That's the position of the player. We don't want, so we're going to apply this to the character to make him turn, but we don't want him to sort of start leaning back. So we need to make sure that the y component of this vector is definitely 0. Now we can't set a player's rotation based on a vector, so we need to change that from a vector into the horrible word quaternion.
So quaternion, basically speaking, is a way of storing a rotation. We have a vector 3, but we can't use that to store a rotation, so we use a quaternion. So we're going to create one called new rotation, and quaternion is also a class that has a number of functions, of which we're going to use one called look rotation.
So what look rotation does, the default for characters and cameras and things like that in Unity and in most 3D modeling, is that the z-axis is their forward axis. So we want to make the player to mouse vector the forward vector of the player. So that's all that this function is doing when we give it the player to mouse.
Then we actually have to apply it. So we're going to address the player rigidbody.
I'm going to use the move rotation function. And since we don't want to give it an offset, we're trying to give it a completely new rotation. We're just going to assign it like that. We don't need to do transform.rotation plus new rotation. It's just this rotation.
Okay, so that's our turning. The next and final function of this, we're going to look at the animation.
Okay, so after the turning, we're going to make another function called animating. Now, we do need to give this the h and v parameters, because whether or not the player is walking or an idle is dependent on the input. So what we're going to do is we're going to create a boolean variable called walking. And we need this to be true if either the h variable or the v variable has some value. If it's 0, then there's no input on that axis. We don't need to worry about it. But if either h or v has a value that's non-zero, then it's true and the player is walking. So what that complicated bit of code there is doing is saying that, first of all, h is that not equal to 0. That will return either true or false, depending on whether it's 0 or not 0. Or is v not equal to 0?
What this is basically saying is, hey, did we press the horizontal axis or did we press the vertical axis? If we pressed either of those, we're walking. If we didn't, we're not.
So the reason that we're doing that is that we want to pass this to our animator component. So remember we made a parameter called isWalking. And the way that we set that is we say anim, so with our reference to the animator component, set bool. So we made a parameter which is a type bool, a boolean, true or false, and it was called isWalking. So first, to actually set this, we tell it which one, so the isWalking parameter, and then we give it a value. So we could here write true or false, but we want to use walking, the variable that we just made.
So the very last thing that we need to do in this function, in this class, is we need to put calls to those functions that we've made. Currently, they're just functions sitting there by themselves. We need to make sure that those functions are actually being called and actually being used.
These three functions aren't happening until we tell them to. We haven't actually called them anywhere in the script. They just exist and are waiting to happen.
In fixed update that we created earlier, we already got the input. We stored that. Now, after we've got the input, we now need to call these functions that we've created. So we call them just by using their name and then passing in the values if they're required.
So move requires two floats. We've got our floats for input there, and that's all that we need to do. So we need to say h and v semicolon. Then we'll call turning, which doesn't take any parameters. And finally we'll call animate, which does. Like that. These are in fixed update, so they're being called every physics step. So that is the end of that script. So what I want you to do now is to go to File, Save, and switch back to Unity. If anything's wrong, you'll see an error at the bottom of the screen in red. When you have no errors in your script, when you press play at the top of the editor, you can move your character around with the arrow keys or W, A, S, and D. The animation should function, but the actual movement of the mouse should be a little bit tricky right now because we haven't moved the camera to the right point. So the camera isn't seeing the entirety of the floor quad yet, and that can be a problem. But we're going to solve that in the next phase. So you should be able to move around. You know, if I move the mouse up away from the floor quad, then it doesn't rotate. As soon as I move it back over there, the raycast kicks back in, and I can turn around and run around like this. Okay, so we're at the end of phase 2. Phase 3 will be just very quickly setting up the camera, and we're going to have a quick look at the script that will make that camera work.